you know, something like pyloric stenosis. I'm doing a baby and I'm trying to show them that the pylorus is open on this baby and I can actually see fluid going in the pylorus. Then I want to change my setting. Then I want to use the least amount of focuses. Then I want to use the least amount of scan density because I'm trying to make sure that my timing is accurate.
So with the least amount of focus, you're going to improve temporal resolution.
Absolutely. So bless you. So right now, with one single focus on this machine, our temporal resolution is already great. It's already high. But if I was to add a more, see the thing about this one right here, guys, the thing about this one, why I don't have multi-focus on this one is because it has a focal zone. See on here, we can change our focal zone. Where my focus? See, I have it right here. I can highlight it and I can make it a small focal zone, or I can make it as big as a screen. So that's why this one doesn't have an actual focus, multi-focuses, because you can extend the focal zone, making your focal zone narrow over the whole image. Okay, instead of just having multiple focuses coming out of the beam, coming out of the transducer. So what this is, the beamformer is gonna make this image to where it has a real narrow, probably exciting those crystals far away from the transducer, because that's how we're going to get a narrower beam over a longer time. So real quick, and I just reviewed off right now. So this chapter course, it starts off talking about frame rate, right? What determines frame rate? Imaging depth, and what else? The speed, which we know speed to be 1.54 kilometers per second. So those are the two things that determine frame rate. Frame rate is what?
Ability to create numerous frames per second.
The ability to create numerous frames per second. The units of frame rate would be hertz, because we have our event and we have our duration, right? So that would be what frame rate is. The ability to create numerous frames per second. Okay? So basically, the more frames we create per second, the better our temporal resolution is going to be. Like I think Myra was talking about this the other day. When you press freeze on here, that number right there, F number on here, is telling you that it's at 640, and it's just been resting. So however long it's been holding 640 frames. 640 frames. So I can go back. However long, I don't know how much time that was, but let's say, I don't know, somebody time me for 5 seconds. Somebody time me 5 seconds. Anybody do it? Where your timer at? And I just want to see how many frames it can hold in 5 seconds. Let's see.
Mississippi.
All right, kind of. Go ahead.
1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5.
Okay. So in 5 seconds, it held 136 frames. So you know that's actually pretty good that we can get 136 frames in 5 seconds. Go ahead.
So what is it for us to do? Hold that translucent there for a little while to acquire the image?
Like that's what I do, because I want a really still image. So I'm gonna just hold my transducer where I need it at. Oh, stop breathing for me. And I'm not gonna hold it 5 seconds, of course, but I'm gonna hold it just so I got some room to come back. You know, same thing if I'm doing a portable and my machine, if I'm on the left side, I may be on this side of the patient because I don't want to be laying across the patient like this. So I may come on this side, look on the screen, get my picture, take my time and walk back. Boom, freeze that. And then go back and find the image I wanted. Okay? Because I'm about, you know, I love ergonomics, so I'm not going to hurt myself. So I go to the other side, get my picture, boom, 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 walk back to this side. You know, if it's just one picture or something like that, I wouldn't do that for a whole exam, because that'd be a lot of walking. Okay? But I brought this in here, guys, because I really wanted to show you, you know, classic. When I get there, I'll show it to you. So, frame rate, the ability to create numerous frames per second. Alrighty. Then we got to talk about frame rate first, because temporal resolution, frame rate is determined by, temporal resolution is determined by the frame rate. Okay? Remember, they have that direct relationship. So if our frame rates go up, the number of frames per second go up, that means our temporal resolution is going to be better. Okay? The more images we can create per second, the better our temporal resolution is going to be. So that's determined by the actual frame rate itself. Okay. Temporal resolution is what, guys? Accuracy in time. Accuracy in time. Accuracy in time. Let me see. Yep. The ability to precisely position moving structures from instance to instance, such as when you're doing the M mode. You know, if I didn't have good temporal resolution, then my numbers wouldn't be accurate as far as getting that heartbeat. Okay. So, then it goes into T-frame. T-frame is the time it takes the system to create one image, okay, which happens to be an inverse relationship with frame rate. Okay, happens to be an inverse and it's a special relationship because it's a reciprocal relationship. So when you multiply those numbers by each other, the total is going to be 1. So that's what T-frame is. So you can calculate T-frame by having what, guys? The number of pulses times what? The PRP, correct? The pulse repetition period, the go and return time. Okay, you can calculate the actual T-frame by that. Okay.
Can you give me an example of T-frame?
T-frame would be, it takes. I think it's a question about T-frame on the homework. Let's say the time it takes to create an image is, I'm gonna give you an example from the PowerPoint. The time it takes to create one image is 1/10 of a second.
That's number 14.
Number 6.
Number 6.
Well, I think it's what is T-frame and what is the relationship with the frame rate?
Inverse and reciprocal. That's what I want you guys to put right there. Inverse and reciprocal. They have 2 relationships. Okay. So my T-frame, it takes me 1/10 of a second to create an image. So automatically, if it takes 1/10 of a second, then I'm creating 10 frames per second, right? Because they have an inverse relationship. So it's just like PRP and PRF. PRP equals 1 over the PRF. PRF equals 1 over the PRP, right? Right. So whatever your number is, you're just gonna put a 1 over it. Especially when they have that kind of relationship, that reciprocal relationship. Okay. So again, like the second question, if I created an image, and I'm creating 20 images per second, then my T-frame is going to be, I'm creating 1 image every 1/20th of a second. After that, it gets into the sonographer control settings. The sonographer control settings that determine that affect temporal resolution. And there's 2 sonographer control settings, right? 2. One is going to be the image in depth, correct? And the number of pulses per image. Okay, and you divide that subcategory, and there's three ways to affect the number of pulses per image, right? But first, let's talk about image in depth. Image in depth, it has an inverse relationship with temporal resolution and frame rate, because as I increase my image in depth I'm on 3.5 right now, I'm able to send a pulse out. Remember, ultrasound works like this. Whenever I send a pulse out, it's listening for those echoes to come back. Another pulse won't come out until it finishes listening to those echoes. Okay, so I'm able to 3.5 centimeters. I'm able to send my pulse out, and then it's coming back. Okay, so if I take my depth to 7, now it's going to take twice as long for me to create that image now, because I've doubled my depth. Okay? I increased my depth times 2. Okay, so now my sound has to travel even longer, but now my temporal resolution is worse because of that, because it's taking so much more time now. Okay, so now instead of at 3.5, I was, creating an image every, 1/5 of a second. Now I'm 1/10 every 1/10 of a second. I would have to double that time it takes. Okay, so image in depth, inversely related to frame rate, inversely related to temporal resolution, directly related to the T-frame. So let's talk about our other stenographer control setting. That would be
Number of posts. Say number of posts, the second.
our number of pulses per image. I believe, I don't know what the order that I went in is, but let's start with the number of multifocus. Okay? We just got finished having a long conversation about that. If I increase the number of focuses, then I'm gonna take that image is gonna take longer. However many focuses I have, that's how many scan lines I have to send out per scan line. So if I have 2 focuses, that means I have to send out two
Scan line.
2 scan lines per wherever which one. So here's my 1 focus right there, 1 focus right here. So instead of it just sending out boom, that's 1 scan line. It's also gonna have to send out. It's gonna go and return down 1 scan line, and also have to send out down that same scan line, go all the way down here, and return back down that 1 scan line. So that's gonna decrease the temporal resolution because now I'm taking more time to create this 1 image, just because I want more lateral resolution. Okay? I want my beam to be thinner over a particular depth. Okay? And like I said, this machine right here, I don't think I have multifocus on here. I think that's the whole purpose of having the large focal zone. That's the purpose of having the large focal zone. But we do have, we can adjust our sector width, right guys?
Mm-hmm.
We can adjust, let me change this to a C5. We can adjust our sector width or our field of view. Remember, that's a synonymous term for field of view is sector width. Okay, so I'll turn that gain up so you guys can see the whole screen. So let's say my sector width was set, because these are questions in the back of the book. If I had my sector width set at 90 degrees and I decrease it to 45 degrees, what's happening to temporal resolution if everything else remains unchanged? But it may have a number, increased by how much? Increased by half, absolutely. So sector width right here, got the button right in the middle. The button right here in the middle, the twist button right here. So change my sector width. You guys see people use it all the time. Like when they're doing aortas, they may use the sector width. Okay? So this is one of the stenographer control settings on this machine is the sector width.
Can we use it as a wider scan too?
Yeah, if you're using wide scan, then you're increasing the number of scan lines. So there's my regular screen. I hit wide scan in the opposite way. Now it's adding more scan lines to this 1 image, decreasing my temporal resolution because now I'm adding scan lines to the image.
Like more pulses, right?
More pulses, absolutely. When I'm using those terms interchangeably.
Well, you certify the temporal resolution, but you get a bigger picture.
Right. I'm getting, and like I said, if I just need a 2D image, then the temporal resolution don't matter to me. Again, temporal resolution only matters if I need to make a movie. If I need to hit this, and I ain't gonna do that, and I need to capture. If I need, I don't have nobody name in there. If I need to make a cine loop. And I just need to make a cine loop, then now temporal resolution matters, whatever I'm trying to do. Okay? But if I'm just needed a static picture, like we only take static pictures. I don't think you guys take any moving pictures.
Not
Right?
yet.
Only time I take a moving picture is when I'm doing a fetus and I'm trying to show the fetal heart. Other than that, I'm not taking a moving picture. So our temporal resolution, honestly, we don't care about it too much. Right? Ultrasound, real-time imaging is already moving fast enough anyway that it looks like it's moving with us. It looks like a movie anyway. Okay. So sector width, imaging depth, and multifocus. Those are stenographer control settings that determine temporal resolution. Right there. And our last one right here, guys, will be
Line density.
line density. Boom. It should be. Oh, it's not on here. Let me see. Man, this one, I think it's on the other one. This is the old one right here. I told you guys we're getting a new machine, right?
Yeah.
Yeah, this one don't have line density on it. Man, ain't that something? Okay. So this one right here, it don't have line density on it. I thought it did though. I think on the Epics it have line density on it. But also remember I told you right here, guys, you can change, you can sacrifice your speed right here. Right here you see where it says resolution and speed. Okay, that's kind of like, do you want your image to be acquired faster, or do you want to have better speed? You want a better speed, meaning your image is gonna be acquired faster, or do you want higher resolution? It's always in the middle right here. It's a toggle switch too. It's always in the middle, but you can change it to whichever side you want to. So look like with the speed, when I go to speed, look like I'm losing contrast, right? It looks like I'm losing shades of gray, because that's resolution, that's speed. It makes it a little darker. And even if you look in the near field, you can see that near field, it changes a little bit. Okay, so that's another way you can affect temporal resolution on this machine, is by choosing between working with the resolution or working with